So, first of all, I didn't post last week because I was in the middle of exams, my midterm exams. Yeah. So, we're going to continue from where we stopped last week. Today's question is on binomial theorem. So, the first three terms in ascending powers of x in the expansion of 3 plus px to the power n are 243 plus 810x plus qx squared, where n, p, and q are constants. Find the values of n, p, and q. So, I think I'm going to do this so we have a lot of space. So you have 3 plus px to the power n, and you have that the first, it says in ascending powers, and you have that the first three terms are 243 plus 810x plus qx squared. And you're asked to find p, n, and q. So first of all, there are some basic binomial theorem terms that you should know by now. That would be, I think you should know up to 5. So I'm just going to write it out. So binomial theorem, I call it the triangle because it looks like a triangle. So the top is always going to be 1, and the sides, like the sides of your triangle, are also 1, right? So the second line is 1, 2, 1, and from there, I think from there it's easier to do because, like I said, your sides are always going to be 1, and then this space, this space here is going to be 2 plus 1, which is 3. This space again is going to be 2 plus 1, which is 3, and then the end is 1. So that's how it's always going to go. You're always going to, for the middle numbers, you're always going to add the diagonal 2 above it. So here in this case, your side is always 1. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and your side is 1. 4 plus 1 is 5. I'm actually going to move this a little bit. 4 plus 1 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1, 5, and 1. So basically, this is how your binomial theorem, triangle goes. That's the coefficient that each number is going to have. So in this case, now let's go back to the question. We have that 3 plus pxn, px to the power n equals this, and this is in ascending powers. Of x. And ascending powers basically means from 1, ascending powers goes up, yes. So ascending powers of x, so from x to 0, x0 to x1 to x2 to x3 to x4. This is what ascending powers of x means, that the powers of x increases. So your first term is a constant. Now, to find what n is, because your first term is a constant, to find what n is, we know that 3 raised to the power n, x to the power 0, because it's ascending, equals to 243. And x to the power 0 is just 1. So 3 raised to the power n equals 243. Now 3 raised to the power what? It gives you 243. I mean, you can use your calculator and multiply, or just multiply. Keep multiplying 3, but 3 times 3 times 3 times 3, that's 4 times 3 is 243. Because 9 times 3 is 27, and and so on. 9 times 3 is 27. This 3 times 3 is 9 as well. So 27 times 9 is 243. Like I said, you can plug that into your calculator if you don't want to go through that process. Okay, so now we have that your n is 5. So we found our n from our constant 243. So we have 3 plus px 3 plus 2px to the power 5 equals, now you now multiply this out yourself. So you have 3 to the power 5 plus, also remember that because you're dealing with 5 here, you're going to use these terms, these numbers. Yeah, that's what's going to be in front of your terms here. So basically you have 1 times 3 to the power 5, then you have 5, because 5 is the next term, your binomial theorem, as you know, an ascending order. So 5 times 3 to the power 4, because it's going down, this 5 is going down, and the px is going up. So you have 3 to the power 4 times px to the power 1. So basically your coefficient, your index, yes, your power should be equals to, your power in every term should equal 5. So this is 5 plus, because every other power here is 0. This is 4 plus 1, which is 5. So your next term will be 10. That's because you have 10 here. 10 times 3 to the power 3, because you had 5, 4, 3 times px to the power 2. Again, 3 plus 2 is 5. You can go further from here, but remember in your original question, you're just working with the first 3 terms, so you don't need any more values from here. So now this is 3 to the power 5 times 1. We already said that 3 to the power 5 is 243. So 3 to the power 4 times 5, that's 5 times 81 px, plus 3 to the power 3 is 9. Sorry, 3 to the power 3 is 27, not 9. So 10 times 27 times p squared x squared. I just because this squared is every term inside the bracket will be squared, so p squared x squared. Now let's continue. So you have 243 plus 81 times 5 is 45 px, plus 27 times 10 is 270 p squared x squared. Now we are going to compare this with the original values they give us this, so we can find p and x, because we've already found n to be 5. So if we bring down the original values they gave us 243, compare 243 plus 810x plus qx squared. Now we can use this because this is already equal, so we can use this to find what p is. So what we have is that 405 px is equals to 810x, and if you divide both sides by 405x, you can find what p is divided by 405x. So this goes, and x goes, of course, and then 405 here is 1, 405 here is 2. Again, you can use your calculator to just divide 810 by 405. So you have that p is equals to 2. Now with this p equals 2, you can now solve for this one, for this last term. Again, you don't need to include your x squared because your x squared is always going to cancel out. So you have 270 p squared, which is 2 squared, equals to q. So 2 squared is 4, so 270 times 4 equals q. So q is 1080. So your final answer, you have 3 plus 2x squared, 2x raised to the power 5. I'm just replacing this here, equals 243 plus 810x plus 1080x squared. So your n is equals to 5, which was this. Your p is equals to 2, which was this. And your q equals 1080, which was this. So that's the answer to question A. Now, so we can transport this here, so you have it all in one page. Yeah. Now your next question, it says find the term independence of y in the expansion of 2y minus 1 over 3y squared raised to the power 6. Give your answer in exact form. Now, first of all, you need to understand what the question is asking you. So the term independent of y is the term that has no y term in it. Well, no y inside. So that term is your constant. So they're asking you to find the constant value of this. Now, okay, I didn't cover 6, so why don't we do that? I mean, so for your triangle, because we need the numbers here to know what we multiply in front of each of these. So let's do for 6 because our term here has 6 in it. So again, your outside is 1. 5 plus 1 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 5 plus 10 is 15. 5 plus 1 is 6 and 1. Right, I hope you do understand what I was doing here. I'm basically adding the diagonal 2 to get the one below. So I'm adding 5 and 10 to get 15. I'm adding 10 and 10 to get 20. I'm adding 5 and 10 again to get 15. And 5 and 1 to get 6. So let's go to part B. What they gave us was 2y minus 1 over 3y squared to the power 6. Now, when we're multiplying out, we're looking for the constant in this. If you can find the constant within the first 3 terms, then, well, good for us. I would say to go in ascending order, because if you go in ascending order of y, go in ascending order of y, this is smaller than this, and if as you increase in y, the negative the y here becomes bigger, so this becomes like y to the power minus 5 or something. It becomes a bigger negative number anyways. So I would say go in the ascending order of y, or you can go anyway, just as long as you find what the constant is. So we have that. We have our numbers here to be 1, 6, 15, 20. 15, 6, and 1. So I'm just going to write that here. 1, 6, 15, 20, 15, 6, and 1. So we're going to start with 1 times 2y to the power 6 as a first term, plus 6, because that's the next term here. 6 times 2y to the power 5 times minus 1 over 3y squared to the power 1. Remember, 5 plus 1 is 6. Your index always has to be equal to 6. Now let's solve this and see. I'm going to write dot 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 because it goes on. I want to solve this to see if we can get a constant, a number independent of y. If we don't get it, we can always continue. So here we have that 2 to the power 6 is, let's see, 2, 4, 8, 16, 32, 1, 2, 3, 4, 5, 64. 2 to the power 6 is 64. So you have 64 y to the power 6 plus 2 to the power 5 is 32. So 32 times 6 is 32y times 6 times minus 1 over 3y squared. Let's see. No, that means, so both of these, which means that both of these still have y in them. So this is y to the power 6 and this is y divided by y squared, which is, there's still y in it. So we're going to move one more. So let's move to the next one. 15 times 2y 4 times minus 1 over 3y squared 2. So basically how I concluded was, because you are looking for the term independent of y, that's the term that doesn't have y. This has y in it, y to the power 6. This, you can say, still has y in it, because basically you have 32y over 3y squared. Now this y cancel this y, you're still going to have y here. So that's why I did one more term to the left and see. Let's see if we have y or not here. So you have 15 times 2 to the power 4 is 16. So 16 y to the power 4 times, so I'm squaring this, right? So my minus is going to disappear and I'm going to have 1 over 3 squared is 9. So 9 y squared squared. So 2 times 2 is 4. Y squared is y to the power 4. Now we see here that this y to the power 4 is going to cancel this y to the power 4. So in this term, there is no y value at all. So that's the term we're looking for. So we can actually ignore this because we don't need this in the answer. So our answer here is going to be just this. And then we have 16 times 15 divided by 9. So 15 times 16 divided by 9. That's your term independent of y, which is, let's see, 3 is 3, 3 is 5. 5 times 16 over 3 would give you 80 over 3. So your term independent of y, your constant term is 80 over 3. Now let's check our mark scheme and see number 4. So for the first question we had n is 5, p is 2, and q is 1080. N is 5, p is 2, and q is 1080. Then for our b, basically have 80 over 3. Yeah, okay, so that is the, there's a lot of calculation in this one, but you just have to know what you're looking for. Again, in B you are looking for the term with the constant term, the term with no y values in it. So we tried the first term in ascending order. Yes, I worked in ascending order here. Now why I say ascending order is because I started this from y equals from 6. I started this from 0. So I went from 6, 5. For the first term I went from 6, 5, 4, and then for the second term I went from 0, 1, 2. So basically I tried the first term and I had y to the power 6. I tried the second term and I had this will give you something over y. So I still had y here, and then I tried this and my y cancelled out. My y to the power 4 cancelled out. So I just had 80 over 3, which means that this was the constant term. Now for this, you could also solve out everything, right? You could continue and say, 22y 3 and minus 1 over 3y squared 3. But you can actually finish out the calculation, but it takes a lot of time, and your exam is time limited, so you want to solve the question as fast and as precisely as possible. Yeah, so that's the end of this video. I'll try to post the next ones within the next couple of days, so that it will help you prepare. Okay, bye for now.